So for my period 2 class, which means Monday, you have not started this activity because we only met one day last week. My period 1 class has started this video. So for those in my period 1 class, I'm going to be completing the entire activity since my period 2 class on A days have not started the activity. So for those of you in period 1, you will need to fast forward to problem number 5 if you were in class last Friday, and go for, and then complete the activity from problem 5. But for everybody else, we're going to start at the beginning. So problem number 1, you're being asked to find the values of x and y. So if you would go ahead and do that. And then in problem 2, you're being asked to take each of these lengths, which is one side of the square, and then asked to finish up the square by drawing the other 3 sides. And then it says find the length of the diagonal, once you've drawn the diagonal end, as a square root, and also find the length of the diagonal in hundredths. So again, try to kind of speed up time here. So if I would draw the other 3 sides of this triangle here, square, this is what it would look like. And then if I would draw the diagonal, which goes right here, that's that green segment there. We're looking for both the length as a square root and the length in hundredths. So again, a calculator will be helpful here. One of the other issues when counting this off, sometimes students will count off the dots. It's not the dots, it's the number of spaces. So this is a 3 by 3 square, not a 4 by 4 square. So go ahead and complete problems 1 and 2, and then when you are ready to have a discussion over or at least see what the answers are, make sure that you're on the right track, turn the video back on. Alright, so in problem number 1, probably the best way to get to x is using Pythagorean theorem, since we have a right triangle here. So 4 squared plus 7 squared equals x squared. X is the hypotenuse, which is opposite the right angle. So we're going to end with the x squared. So 16 plus 49. So x squared is 65. So x is the square root of 65. That would be the answer to this, to x. Y has a couple of different ways of getting there. One way would just simply be to use Pythagorean theorem again. So we have 64 plus 196. So y squared is 260. So y is the square root of 260. Another way of getting there, if you would recognize that the scale factor between the 2 triangles is 2. So 4 times 2 is 8, 7 times 2 is 14. So if I take that length there, the square root of 65, and if I would double it, another answer for this would be 2 root 65, or 2 times the square root of 65. All right, and so problem number 2, again, if I draw the other 3 sides of the square, this would be a 2 by 2 square. That's the diagonal. This is a 1 by 1 square, and that would be the diagonal. And this would be a 4 by 4 square. And there's the diagonal, and then here we have a 5 by 5 square. And this is the diagonal. So Pythagorean theorem would be the way to do these. So like be doing like 3 squared plus 3 squared to find the hypotenuse. So I'm not going to go through all the Pythagorean theorem work here. I'm just going to go through the answers, and hopefully at this point you've done enough work with Pythagorean theorem that you're getting the same answers. So basically 3 squared plus 3 squared, so 9 plus 9 is 18. So this one is the square root of 18. This one, hopefully you got the square root of 8, because 2 squared and 2 squared, so 2 squared is 4, and 2 squared is 4, so 4 plus 4 is 8, so this would be the square root of 8. Hopefully you said this one here would be the square root of 2, because 1 squared plus 1 squared is 1 plus 1, which is 2. Hopefully you got this one here to be the square root of 32, because 4 squared plus 4 squared is 16 plus 16, which is 32. And hopefully you said this one is the square root of 50, because 5 squared plus 5 squared, which is 25 plus 25. As approximations, and run to the nearest hundredth, square root of 18, hopefully you got approximately 4.24 for the decimal number. Again, if you stick it in the calculator, comes out to be approximately 4.24. Square root of 8, hopefully you got about 2.83. Square root of 2, hopefully you got 1.41. Square root of 32, hopefully you got 5.66. And the square root of 50, hopefully you got 7.07. 7.07. I said it right, didn't write it correctly. So again, square root of 50 is 7.07. Okay. All right. Next problem here, they're asking you to take these answers, these square roots, and actually simplify them. So you have the square root of 2 was one of the answers. The square root of 8 was another one. 8 square root of 18. The square root of 32, and then the square root of 50. Now I'm going to just kind of go through a discussion of how you do these problems, and then Wednesday and Friday, for those of you who are doing this for the first time, we'll spend more time in class working on these. But what you need to understand is that to simplify square roots, you have to use certain numbers. And those numbers are perfect squares. In other words, those are the numbers that you can actually take square roots of and get a whole number answer. So these are some of the square roots that we could choose. So when we are simplifying these problems here, we're trying to use these numbers here that I'm circling, trying to identify, are any of these numbers here factors of the numbers underneath the square roots? And if the answer is yes, then that means that square root can be simplified. But you can only use these perfect square numbers. Again, the next one would be square root of 100, which is 10, and so on, because those are the only numbers that you can take square roots of and get a whole number answer. So for the first one, since the smallest number that we can use is a 4, and this number actually is a 2, this is as simplest as you can get it. You cannot simplify the square root of 2 any further. In the case of the square root of 8, we actually have one choice, because we have 4 and then 9. Well, 9 is bigger than the 8, so there's only one choice if this can be simplified, and it can be, because 4 actually is a factor of 8, and the other factor is 2, since 4 times 2 is 8. So the first number is a perfect square, which means we can simplify it. The second number we cannot, because it's not a perfect square. So the square root of 8, if I simplify it, square root of 4 is 2, and then the 2, this 2 here is still under the square root because it's not a perfect square. So square root of 8 simplifies to 2 root 2 because of the fact that we can take the square root of that number. So go ahead, and I'm going to give you a little time here. Can you come up with a way of simplifying those three? And if so, turn the video back on when you're ready to continue. So for 18, the you have three choices: 4, 9, or 16. Those are all the numbers smaller than 18. And 9 actually works here again. 9 times 2 is 18. So the square root of 9 is 3. And so this simplifies to 3 root 2, because the 9 can be replaced with 3, and the 2 stays underneath the radical. For 32, we have all of these choices. Again, when we're simplifying these, you're always looking for the largest perfect square. So actually 2 of them work here. 4 works, so does 16. But we're always looking for the biggest number. So it would be 16 times 2 is 32. Square root of 16 is 4. Again, the square root of 2 we do nothing with because you can't simplify it. And then the last one, we have 6 choices. 4, 9, 16, 25, 36, and 49. And the only one that works is the 25. And that's 25 times 2. Square root of 25 we can actually do, that's 5. And then the 2 stays underneath the square root. Now, what I want you to understand here is that by taking the square roots from the previous page and simplifying them, they all ended up with a square root 2 in it. So that's a pattern that's very important for working with what we call a half square. So we're taking a square here, we split it in half. So this one here was 3 root 2 when we simplified it. This was 2 root 2 when we simplified it. This actually was simplified. This one here was 4 root 2, and this one here is 5 root 2. Okay. So a couple things you need to understand is that when I have these two numbers here, the hypotenuse is going to have the 3 in it times root 2. If I have the two numbers here being the same, then the hypotenuse will be that same number, 2, times root 2. And that's true for the 4, 5, and even the 1. This is 1 root 2. So that's some of the patterns that we're going to be using here. I'm jumping to problem 5 because of time. So if I want to go from here to the hypotenuse, basically I'm taking this number and I'm multiplying it by the square root of 2. If I'm going the other direction, I will be dividing by the square root of 2. So going from a leg to hypotenuse, I'm either multiplying by root 2 or dividing by root 2. If I'm going from a leg to a leg, I'm either multiplying by 1 or dividing by 1 because they're the same number. So these two are the same. And if I take 3 times root 2, I will get 3 times root 2 or 3 root 2. And that's the answer for one of the problems on the previous page. So for the last two problems, can you figure out what the two missing numbers would be? Turn the video back on when you think you have an answer, and we'll take a look at those. I'm going to start with the last one because we have a leg. So if I'm going from a leg to a hypotenuse, I will be multiplying by the square root of 2. If I'm going the other direction, I will divide by the square root of 2. If I'm talking about the two legs, they're the same number. So basically I'm multiplying by 1 or dividing by 1. So this is 14 and this is 14, the same number. And then this is 14 times root 2. So the hypotenuse is 14 times the square root of 2. Here I'm going from the hypotenuse back to the leg, so instead of multiplying by the square root of 2, we're actually dividing by the square root of 2. So this time we're dividing by the square root of 2. So what we get is 24 divided by the square root of 2. And that's true for both of these because they're both the same length. This is an isosceles right triangle. So if we want a decimal number, we could just stick those into the calculator. But for right now, that would be the length. Those would be the lengths for that triangle, and that's okay for right now. So starting at problem 6 to the end, I would like you to complete these problems, and this is for everybody. And these are going to be considered homework problems due for the next class. And you do have time in class. You can work together in a group of 2 if you want to work with a partner. And then again, all these problems are kind of covered as special right triangles from this lesson. Can you use the information that I discussed here, plus what we talked about last week, to do problems 6 through 10, and then bring these answers to class next class. And then transition it next to the third and final activity.